Welcome to the Calculus A section. We have discussed in prior how to differentiate or take the derivative of basic functions. Now we will be dealing with derivatives of trigonometric functions. But before we delve into the notation, we need to understand two facts. So here we have the limit as theta approaches 0 for sine theta over theta. Now this equation is always going to be equal to 1. Now there may be renditions, say sine 2 theta over theta, and that is going to be equal to 2, or maybe sine 2 theta over 6 theta, which would be equal to 2 over 6, or 1/3. Now, it's important to understand why. So as theta approaches 0, our sine is also going to approach 0. But if we have, say, 0.001, we'll also have 0.001 over the denominator, and any number divided by itself is going to equal 1. Now similarly for cosine theta, we know that when theta is approaching 0, cosine theta minus 1 over theta will also equal 1. So we can have other renditions of this as well. We can say cosine 2 theta minus 2 over, let's say, 2 theta is also going to equal 1 as well. And also for the similar reason, when cosine theta is actually approaching 0, we know that it's going to equal 1. So if we subtract 1 from that, we are actually going to approach 0. But if we approach that very small number, any number divided by itself is actually going to equal 1. Now here we have the functions, 6 trigonometric functions to be exact, and here we have the derivatives. So for the first one, we have the derivative of sine x is going to equal cosine x, its counterpart. And for the derivative of cosine x, it's going to be negative sine x. Now this is an important differentiation, and it is negative, and that is important to note. Negative. Okay. And the derivative of tan x is going to equal secant squared x. We can write it as that, or we can also write it as secant squared x. It's the same thing. And now the derivative of secant x is going to be secant x tan x. So it does have itself in it. And the derivative of cotangent x is equal to negative cosecant x squared, or also written as negative cosecant x squared x. And the derivative of cosecant x is going to be negative cosecant x times cotangent x. And the way I like to remember these secant ones is they have themselves in it. So secant is similar to selfish, and the tangent ones have their counterparts into it, squared. While cos, anything with a co in it, is going to be negative. So cosecant, cotangent will always have negative beginnings, and additionally the secants are selfish, so they're going to have themselves in it, and the tangents are going to have squares in it. That's just how I like to remember it. But other than that, that is the derivatives of trigonometric functions. It's basically identities that should be memorized because they will be utilized throughout the entirety of calculus. So I hope that helps, and if you need more problems or more help, the website has a bunch of insight. Thank you, and I hope that helps.